in basic functions in Python. Let's get started. Okay, here I am at a fresh Jupyter notebook. As a quick note, the lecture notebook that goes along with this is called Functions, and throughout this series of lectures when we talk about things like print versus return, adding in logic inside a function, tuple unpacking, etc., that's all within this singular Functions notebook. So it's a longer notebook that's going to have several video lectures attached to it. Okay, let's get started. As we mentioned, you first have to start off with the DEF keyword. Notice that it starts highlighting the special syntax behind it, and then we decide on the name of our function. For example, let's have a function called say hello. Then we have open and close parentheses and the colon. And then when you hit enter, you'll notice an automatic indentation, which happens after you click a colon in Python. And basically what that means is anything inside this indented block is going to be called when you execute the function. For example, if I say print hello, run that. Then, if I later on, somewhere else in my code or script, call say hello, open and close parentheses, then it's going to execute the block of code inside this function. That means that if I had more complex code, like a bunch of print statements, hello, how are you, imagine for a second that I wanted this all in 3 lines for some reason, then I no longer need to write those print statements 3 times. Instead, I just need to call say hello 1 time. Now note here the difference between calling say hello with parentheses versus without parentheses. If you call it without parentheses, then it's actually not going to execute the function. Python will just report back that say hello is a function. Keep that in mind, that when we're calling functions, in order to execute them, we have to add on this open and close parentheses. So if you see something like this, it means you're not actually calling the function. You need to add on the parentheses. Okay, so the main point of a function is to execute the block of code, especially when you plan on repeating that block of code. And realistically speaking, we're probably going to take some input parameters or input arguments into our function. So let's go ahead and continue. I'm going to overwrite say hello. And then I'm going to say, let's go ahead and call this name, that it takes in some name parameter. And then it's going to print out using an f-string literal here, hello, name. So what is this doing? Well, it takes in some argument called name, and then it's going to insert it right here so that it will report back hello name, which means if I call say hello, and I pass in the string Jose, it says hello Jose. A couple of things to note here. Technically, I can call this variable whatever I want. So let's go ahead and show that. I could call this jelly, and then this would have to match up here, jelly, run that, and it looks exactly the same. So typically what you should be doing is just providing variables that make sense to you. In this case, name makes a lot of sense. The other thing to note here is let's imagine I forgot to pass in an actual value. So I just said say hello. Well, in this case, Python is going to complain. And the way to read this error is it will say it's missing one required positional argument called name, which is essentially trying to tell you, hey, we need to know what name is as an argument in order to actually execute this block of code. So how can you fix this? Well, one way is just to provide the value as mentioned. Another way is to provide what's known as a default value. And you do this with an equal sign up here, and you can provide some default value. So what this means is if name is not provided, then we'll go ahead and use this default. And in this case, we'll just say equals and whatever you want the default string to be. In this case, I literally just put it as default. So make sure you keep running these cells in order to overwrite your old function code. And then let's call say Jose or say hello Jose. It says hello. And now what we're going to do is leave it blank. Previously, when we left it blank, we got an error. But now that I reran this function definition and run this cell again, it says hello default. So it no longer produces an error. Instead, it will reach in and find the default value for that function. All right, now as we noted in the previous lectures, typically when it comes to a function call, you're not actually just going to print stuff out. Instead, you're going to use the return keyword. So let's see an example of that. I'm going to create a function called def add num, and it takes in 2 numbers, num1 and num2, and it's going to return their sum. Return num1 plus num2. And one of the most common questions I get from beginning students is what's the difference between saying print in a function versus return in a function. And the main difference is that return, instead of just printing out the results, is actually going to allow you to save them as a variable. So we'll say add num here, and in Jupyter Notebook, if I were just say something like 1020 add num, notice that I see the result anyways, 30. But because I'm using return, I'm actually able to assign it to a variable. So I can assign it to a variable instead of seeing the result, and then call later on somewhere in my code that result. So let's actually see this between two functions. We will call one print result that takes in two parameters. Let's go ahead and call them a and b this time. And this one just prints out the sum, a plus b. We'll create a very similar function called return result. And this one is going to return a plus b. This way we can actually see the true difference between them. So let's first start off by running this print result function. So I will say print result. I pass in 10 and 20, so 10 plus 20 is 30. And when you run this, notice it prints out 30. You should also notice that unlike before, there is no output cell showing you that a variable is being returned. Instead, it's just printing out the result. So let's imagine that I wanted to actually save the result 30 to some result variable. What I cannot do, since I'm just using print, is the following. If I say result is equal to print result, then Python is just going to print this out, and it's not actually returning anything to this result. In fact, if I check result and try to run it, I don't get anything back, because the type is none type. Because again, print result is not actually returning anything to be saved. It's simply printing an output and then closing off the function. In order to actually do this sort of thing, where I want to save the variable, I would need to return a plus b. So let's see the return result function now. I say return result 10, 20. I see 30 is the output. Note that Jupyter lets you know something's being returned by showing you this output cell, just signifying that it's not being printed, it's being returned. And now what I can also do is say result is equal to return result. And now if I call result, it's actually the number 30. So again, just having print here is not going to allow you to actually grab the result. Now that doesn't mean you can't use print and return together. If for some reason, keep in mind it's not super common to do this, that you wanted to see both the printed result and be able to return it, then you could just do something like this. You could say def, call it myfunc, takes in a plus b. It will go ahead and inform the user by printing out a plus b, and it will return a plus b. Now this is not too common to do this. You usually either just return or just print. Most common just return. But if for some reason you find yourself saying, in my large script, I want to be able to kind of view the results as they're coming in, then you could print and then also return, which kind of allows you to get the best of both worlds, so to speak. So I could say result, my function, 10 and 20, run this. Notice that this print gets executed, but then this return also gets executed. So now result is equal to 30. Again, not super common to do this, but when you're debugging sometimes as a beginner, it is useful to have these print statements within a function, so you can see what's going on internally. Now the last thing I want to point out in this lecture is the fact that we were just saying a plus b in the function. But keep in mind, we weren't actually checking what the data types were. So if I called a function sum underscore numbers, it takes in num1, num2, just as before, and it returns num1 plus num2. Nowhere in this am I actually checking to make sure these are numbers. And if you're coming from another programming language that is statically typed, that is to say you have to make sure and define the data type of a variable before you call the variable, then you may not be used to this. Python is dynamically typed, which means I don't need to specify beforehand what data type I expect num1 and num2 to be. That allows you to program a lot faster, but it also leaves you open to possible bugs. Let me show you what I mean. If I say sum numbers, and I say something like 10 and 20, I get the result I expect, 30. But that can get dangerous when I say something like sum numbers, 10 as a string, and 20 as a string. Since these are strings, the add sign will actually concatenate these together, meaning I get the result 1020, which almost looks like 1020, which is not what I was expecting here. And when you're taking user input, it will show up as a string. So recall from the useful operators lecture that the input function returns a string. So that means if you find yourself creating a function that another user will be interacting with, you should probably be making sure to check the type of the data before returning the result. And we're actually going to have a much deeper discussion on this when we start heading towards your milestone project. So keep that in mind for now, and later on we'll show you different ways of having to deal with this and making sure the right data type is being returned by a user. So keep this in mind for now. Later on we'll show you various ways of potentially addressing it. Okay, that's it for now. Coming up next, we'll show you how to add in logic to internal function operations. I'll see you back, everyone, to this lecture on using functions with logic. We already know a lot of logic statements within Python, things like for loops and while loops, if statements and else statements, and so on. So what we're going to do is to begin combining that knowledge with the ability of a function. So let's get started. We're going to start off with a very simple function that just checks whether or not a single number is even, and we'll expand the complexity from there. Let me head back to the Jupyter Notebook. All right, here I am in the Jupyter Notebook. I want to do a quick recall about the mod operator, which essentially returns the remainder after a division, which means if the mod operator is end up equals to 0, then the number is evenly divisible by whatever the mod operation was. So to give you an example of this, if I were to say 2 mod 2 and run this, then the result is 0, because 2 divided by 2 is 1, remainder 0. If I were to say 3 mod 2, then 3 divided by 2, 2 goes in once into 3, and then there's a remainder of 1. So recall that this mod operator just returns back the remainder after division. So for example, if I were to say 41 mod 40, take a second to figure this out, basically it should be remainder 1. Since 40 can go into 41, 1 full time with a remainder of 1. Okay, so how can we use this to check if a number is even? Well, if a number is even, such as 20, then I know that that number, mod 2, should be equal to 0. So essentially, any number I put in here, if I provide the mod operator and it ends up being equal to 0, then I know it's even. If not, then it's not even. So for example, I could do a check like this. I could say 20 mod 2 and check for equality against 0. Because I know if the result of this mod 2 is equal to 0, then I have true, it is an even number. Otherwise, such as 21, odd number, and I do mod 2, set it equal to 0, then that's false. Okay, so let's construct this into a function. That way we can place any number here instead of having to manually type in 20 and 21. We start off with the keyword, def. Call your function whatever you want. I will call mine even check. Notice the snake casing here. We have to pass in an argument. I will call the argument number. This is where you have flexibility on what you want to call it. And then what I need to do is inside of this, I need to say the number mod 2 equals 0. And so what this is going to do is if I say something like result is equal to number mod 2 equals 0, I could return the result, run this, and then I can have even check. And so even check 20. 20 is true because this is true, so the result is true. And then I can say even check on 21, and it returns false. 21 is not even. Now, for beginners, it's really common to separate things out into multiple lines like this. But keep in mind, I don't actually need to save this as a result parameter. Instead, I can directly return number mod 2 is equal to 0. So if I paste that in, this is actually the exact same thing. So if I run this again, I get the same results. So again, it's really common for beginners to kind of duplicate lines when really you can just return something that is the Boolean check. So we have a function that can check if a single number is even, and then it returns back a Boolean, true or false, whether or not it's even. Let's go ahead and check inside of a list. So what I'm going to do here is I'm going to start off a new function, and this function is going to return true if any number is even inside a list. Okay, so again, there just has to be a single even number inside of a list, and the list can be as long as you want, and it's going to return true if that happens to be the case. Otherwise, it will not return anything. So we'll say DEF, and I will call this now check even list. It takes in a parameter, and now this parameter is going to be assumed to be a list. So we'll say numList. And what I need to do is I need to loop through each number. So we're going to start adding in logic that we already learned about, like a for loop. So I can say the following. For every number in the numList, and recall numList is going to be passed in by the user, I'm going to have another colon here. And notice how now we have different layers of indentation. I have this first one, which is everything inside the function, and now I'm going to have this second one, which is everything inside this for loop. So, for number in numList, first let me check if I get a so-called hit on an even number. So if that number, mod2, is equal to 0, well, I'm technically already done. Since I'm just checking if any number is within a list, then the very first time that I hit an even number, I can pretty much return true. So I will say, whoops, forgot my colon there. If number mod2 is equal to 0, I'll return true. So note here that I'm going to go through every number in the list, and the very first time I get number mod2 is equal to 0, then I go ahead and return true. And what I'm going to do is say else, and I'm going to use the pass keyword. And pass just means don't do anything. So let's go ahead and look at the logic here. I pass in this list of numbers. I start going through every number in the number list. If I get an even number by saying if true, then I go ahead and return true here. Else, so let's say this is an odd number, I'm just going to pass. I'm not going to do anything. So notice here, return is actually in the middle of the function. It doesn't always have to go at the end. And in fact, we'll show you in just a second how you can have multiple returns inside of a function. So let's first check that this actually works. I'm going to say check even list, and let's pass in a list that has all odd numbers. Notice nothing is returned. Now let's say check even list that has 2 even numbers in it, and it returns back true. There is an even number there. And let's do a couple of edge cases just to make sure this is working. Let's go ahead and have the first number be even. It returns true. And let's go ahead and have the last number be even. And that also returns true. Okay, so it looks like it's working. So what it's doing is just looping through these numbers until it finds an even one, and then it just breaks out of the function and returns true. And in fact, you can think of this return statement as essentially going to break off the entire function and end the function call. Once you call return, that's it. The function's over. It's not being run anymore. So currently, our function doesn't return anything if there is no even number in the list. Let's say we actually want it to return false. How can we fix this? A super common mistake that a beginner would make is they would simply change else here to return false. However, this is wrong. Why is this wrong? Well, I just mentioned you can think of return as essentially breaking out of this function. So why is it wrong to put return false here when it was correct to put return true? Often beginners make the mistake that all the return statements should have the same level of indentation, but that's actually not true. Because look what's going to happen here. We're going to say for number in number list, and then the very first time that a number is not even, we'll say, okay, in other words, just return false. Essentially saying that this if-else statement is only going to be able to check one number because both conditions will immediately return something. So if I were to actually run this, let's go ahead and run this on, let's say 135. So that returned false correctly, but now let's put in a 2 there. It should return true, but notice it returns false because it's essentially only checking the first number since there's a return call on either condition that the first number has. So that means this return should actually not be here. In fact, where should it be? Well, I want to make sure I've already checked every single number and whether or not it's even by the time I return false. So the return false should actually be in indentation with the for loop here. So what this says is go ahead and complete the entire for loop. If this has completed and we never broke out of the function with this return statement, then go ahead and then return false. So let's go ahead and run this and see if that works. So notice 125 returns true. If I change this to 135, now it correctly returns false. Again, a super common mistake beginners make is they think all the returns have to be indented together. But we can see we really need to focus on the logic of what's happening here. We want to loop through all the numbers first, and we can use these pass statements as placeholders to essentially say, don't do anything. And that will be very useful when you have a function that needs or requires multiple return statements. Let's expand this one more level of complexity. Let's imagine that we actually want to return all the even numbers in the list. So I don't just want to say true or false, is there an even number? I actually want to return them. So let's go ahead and start adjusting our check even list. So again, what we want to do here is I want to return all the even numbers in a list. And if there are no even numbers, we'll go ahead and just return an empty list. So what do I need to do here? Well, this code may come in handy, so I'll keep it for now. But what I'm going to do is start off with an empty placeholder list. We'll say even numbers is equal to an empty list. And it's very common at the top of a function call, if you intend on returning something, if you don't have it defined as an argument, that you define it up here as some sort of placeholder. So often you'll have placeholder variables at the top of a function. So here, even numbers is essentially a placeholder for what I eventually will return. And so I'm not going to be returning true or false anymore. What do I actually want to return? I want to return the list of even numbers. So what I'm going to do here is I'll still go for every number in the number list. If I do happen to have an even number, I will append it to my even numbers list. I'll say even numbers dot append, and it's called number here. So I'll copy and paste number. Okay. So again, I'm going through the number list. If I attach an even number, I will append it to my list. Otherwise, I don't want to do anything if it's not even. And then just as before, I want to make sure we've looped through every single number in the number list before I return even numbers. So I'll come back here and say return even numbers. So again, the return here is lined up with the for loop because I want to go through the entire logic of the for loop, and only when there's an even number do I do something. And then I return the even numbers list. Let's go ahead and check this out. I'm going to delete a couple of these. So we'll say check even list. If I say 1, 2, 3, 4, 5, I run that, it returns back 2 and 4. Looks like it's working. If I say check even list 1, 3, 5, all odd numbers, I get back an empty list. Okay, that's it for this lecture. Coming up next, we're going to discuss about returning tuples for unpacking with function. Everyone, in this lecture, we're going to discuss functions and returning multiple items from a function with tuple unpacking. Let's get started. Now recall that we've previously seen we can loop through a list of tuples and unpack the values within them. For example, let me create a list of tuple called stock prices. And what I'm going to do here is the first item will be a ticker and then that stock's price. So we'll say Apple is at 200, and I'm just completely making up these numbers. Then we'll say Google is at, say, $400. And then finally, we'll say Microsoft, $100. Okay, so we already know that I can actually say for item in stock prices, print item, and it prints out the tuples. I also know that I can do tuple unpacking, which means I can actually individually grab the items from these tuples. So I can say for price, or actually for ticker and price in stock prices, print, let's say, just a ticker. Run that, and what it's doing is it's unpacking ticker and price separately, so I can do different things with them, such as ticker, or maybe I can say print price plus, let's say, 0.1 times price. So I want to see what a 10% increase would look like. So I can run that, and now I can see a 10% increase in the prices. Okay, so that's tuple unpacking. Now we've seen how we can do it with a for loop, but we can also do it with a function. So a function can actually return things as tuples, and then we can unpack the result from the function. So let's go ahead and do kind of a more complicated example here. I'm going to say work hours, and this is going to be a list of tuples that has an employee name, let's say Abby, and then the hours they happen to work that particular month. So we have Abby at 100 hours. Let's go ahead and have Billy at 400 hours, just kind of making these up. And then let's have Cassie, whoops, make sure that's a string, at 800 hours. So kind of extreme values here, but they're totally made up. Okay, so we have these work hours over some period of time. And now what we want to do is we want to see who is the employee of the month or the employee of the year. And the way we judge that is by the employee that has worked the most hours. And we want to return not just the employee name, but also the amount of hours worked. So I need a function that can actually then go through these tuples and then see the name and the corresponding hours and keep track of the name that has the most hours. So how can we do this? I'll create a function called employee check, and it accepts this list of tuples, work hours. And then as I've stated before, typically we're going to have placeholder variables when it comes to logic at the very top of a function. So I'm going to have two placeholder variables. I'm going to have a current max, and I'm going to set it equal to 0. And then I'm going to have an employee, let's say of the month in this case. We'll say employee of month, and that's equal to an empty string. Because at the end, I intend to return a tuple. So I intend to return a tuple that says employee of the month along with the current max, which is the current max hours. So why do I have current max equal to 0, and what is current max going to do? Well, what current max is going to do is it's going to start off at 0, and then it's going to compare each employee's hours to the current max hours. And if they beat the current max hours, then I will reset the current max to their value, and I'll reset the employee of the month to this string. So we have to do a for loop to see this. We'll say for, and here we'll do some tuple unpacking, for employee, comma, hours, in work hours, which recall is this list of tuples. What I'm going to do is I'm first going to check if the hours that they've worked is greater than my current max, then I'm going to reset my current max equal to the hours that that particular employee worked. And then the employee of the month is going to be equal to the employee in that tuple. So what does that actually mean? Well, recall that my current max starts off at 0. So immediately, the very first person I see has beat, supposedly, 0 hours. So that means Abby starts off as employee of the month, and my current max hours to beat is 100 hours. Otherwise, I'll simply pass. So let's go ahead and see what happens when we reach Billy. We see Billy, we extract Billy's hours is 400. Is that greater than the current max hours? Well, in this case it is, because Abby only worked 100. So then I reset the current max, essentially the target to beat, as 400, and then I set Billy as the employee of the month. And I keep going throughout this. So then Cassie is going to end up beating Billy's 400 hours, and then she'll be the employee of the month. And what I'm going to do is return this then as a tuple. So again, here's all the code. Let me go out one level of zoom so we can see this all. Going to run this, and let's run our employee check. And I'm going to run it on my current existing work hours. That's the variable we first assigned. And as we suspected, Cassie won. So let's make sure this is working. Let's go ahead and say Billy worked 4,000 hours. So we run this again, employee check, run that, and now I see Billy 4,000. So again, what it's doing here is it's just tracking who worked the max hours, and essentially who do we have to beat. And eventually what's going to happen is we'll find out who worked the max hours, because no one will start beating this equation right here of hours greater than the current max, which means we never ended up resetting current max, and we never end up overriding that employee of the month. So essentially, once Billy comes in and he hits 4,000, Cassie doesn't end up beating him with 800, so Billy stays as the assigned variable employee of the month. Now we just saw this returned back this tuple. So what we can do is two things. I can either say result is equal to employee check, and if I take a look at result, it says Billy 4,000, Or just as before with the for loop where I said ticker comma price, I can do the same thing if a function returns back this tuple. So it's really common to see something like this. I can say name comma hours is equal to employee check work hours, run that, and note what happened. Unlike before where results, if we see it here, is the tuple, I did tuple unpacking, and now I have the name Billy and hours as separate variables. So I can actually perform tuple unpacking with a function call. Now, a really common error is when you're using someone else's function or a function from a different library that you're not too familiar with, maybe we think that, oh, this function also gives the employee's location. So let's see the result here. Let's say name, comma hours, comma location. Now I know for a fact it doesn't report back the location. If you run this, you get an error. And this is a very common error where it says not enough values to unpack. And very common error to get when you're dealing with functions that you don't 100% know what they return. So you notice here, it actually tells you, hey, expected 3 got 2. Expected 3 is basically what you expected. You expected 3 values, but you only got 2. So how do you actually deal with this sort of error? The easiest way is to just assign everything to a single item and then begin exploring that item. And then you can see, oh, I only have those 2 values and it looks like it was a name and the hours. I don't actually have a third location item. All right, that's it for returning tuples for unpacking. Again, you can review this when we discussed for loops as far as tuple unpacking within a for loop, and you can kind of review this function call in the lecture notebook. If you have any questions, feel free to post to Q&A forums. We'll finish off this lecture series by just creating a very simple function program that essentially shows interactions between functions. I'll see you at the next everyone to this lecture on interactions between functions. Typically, a Python script or Python notebook contains several functions interacting with each other. We take the results of one function and often use that as input to another function. What we're going to do is we're going to create a few functions to attempt to mimic the carnival guessing game 3 Cup Monte. And in case you're not familiar with this, it's basically you start off with 3 cups and underneath one of them is hidden a red ball. And then what you're going to do is you shuffle these cups around, have the user guess where the red ball is, and then they're either right or wrong. So our very simple game won't actually show the cups or ball. Instead, we're going to mimic this with the effect of a Python list. So it's going to be a Python list with 2 empty strings and then 1 string that has just a capital O, which will be our ball. And our simple version will also not show the shuffling to the user, so the guess for the user will just be completely random. Our main focus here is to show you how multiple functions can end up interacting with each other and returning objects to each other. Okay, let's get started. All right, here we are in the Jupyter Notebook. To begin, I just want to show you how you can shuffle a list at random in Python. And Python actually comes in with a built-in random module, and we covered this module in more detail later on. But for now, I'll show you just the shuffle function that can come from the random module, and we'll show you how to import it. And we'll talk a lot more about imports later on in the course. But for this case, let's go ahead and make an example list. Let's say it has 7 items in it, and I want to randomly shuffle the list. Well, I can say from random import shuffle. And the shuffle function will actually shuffle a list in place, meaning it doesn't actually return anything. It just grabs that current list and then shuffles it. So we can say shuffle the example list, and then when you call example again, you'll notice that it's been shuffled. So we're going to be using this built-in shuffle from the random module inside of Python within one of our functions. So let's start by creating our simple game. First, I'm going to create kind of our own version of shuffle, which actually returns the example list. Notice shuffle example here doesn't actually return anything. For example, if I were to try to say result is equal to shuffle example and then call result later on, it's actually happening all in place within the example list, so nothing is returned, which means I can't actually do this. So what I need to do is create my own function for this. So say def shuffle, and we can't call it shuffle because that's the same name as the function space and we can't share that namespace. So we'll say def shuffle list, which is going to take in my list it will shuffle my list, and then it will also return my list. So adding just a little bit of functionality on top of the built-in shuffle. Since the built-in shuffle won't return anything, it just does it in place, and I actually want to be able to return it and use it as a result here. So let's see if this works now. I'll say result is equal to shuffle list. Let's pass in our example. We check out our result, and it's shuffled. And each time I run this, you'll notice it kind of shuffles it in a different way. Perfect. So we have a function that can shuffle this list. So what is our actual game list going to look like? Well, as I noted previously, our game list is just going to be 3 strings, with one of them being essentially a capital O as our red ball, and the other 2 are empty strings. So what the user is going to try to guess is, where is this hidden capital O? So eventually what we're going to be doing is calling shuffle list on my list, and then it will shuffle this around, and the O may or may not be in the same spot. Next, we need to create a function that can take in a player guess. So the player, after the list has been shuffled, is going to guess the location, and we won't display where the list is before we shuffle. So what I want to show you is a function called player guess. And this takes in no arguments. Instead, we start off with a placeholder of the user's guess. And the user can guess essentially one of 3 index positions. They can guess it's either index 0, index 1, or index 2. So we start off with an empty guess, and then we'll say guess is equal to input function, and we'll say pick a number 0, 1, or 2. Now, in order to make sure that the guess is actually correct, we could add in some extra code here. Basically, as we mentioned before, we can use a while loop to make sure that the input is correct. So I could say while the guess not in 0, 1, 2, colon, go ahead and keep asking for this input. And then once that's finalized, go ahead and return the integer version of guess. You may be wondering, why are these strings, and why are you casting it as an integer at the end? Well, that's because input returns and always returns a string. So even if you type in the integer 0, 1, or 2, it's going to return it as the form of a string, which is why we're checking the string 0, 1, and 2, but I'm returning it as an integer since I will use it to directly index off this list. Let's go ahead and run this so you can see what it looks like. I call player guess, open close parentheses, run this. It says pick a number 0, 1, or 2. If I provide an incorrect value, because of that while loop, it'll keep asking me over and over again until I get either 0, 1, or 2. So if I pass in 1, that's perfect, and then I get the result 1, which I can save. So I could say my index is equal to player guess, run this again, and if I pass in 2 this time, you'll notice that my index is now 2. Perfect. So we just need one more function, which is to essentially combine this list that has been shuffled with the player's guess. So I just need to check that my guess was correct or not. So we'll say check guess, and this is where the functions begin to interact with each other, because I will pass in my shuffled list and I will pass in the user's guess. So that means I should have called player guess and my shuffle list function before calling this check guess function. And so what we're going to do at the end of this notebook is write a little script that essentially calls the functions in the correct order. So we'll say def check guess, and we'll say if my list at my guess index position is equal to a capital O, then I'll simply just print correct. Else, I will print wrong guess, and let's go ahead and tell the user where it actually was by printing out that list. Note, in this case, I don't actually care about returning anything because this will essentially be the last line in my little script. So I have my functions defined, and now it's time to set up a little bit of logic as a final script. So if you're dealing with this in a .py file, it's very common to have a bunch of function definitions at the top, and then at the bottom, you have the actual logic to be called here. So what I need to do is set up my initial list, then I need to shuffle that list, then have the user guess the location, and then I will check against the list with the user guess. So how do we do this? We'll start off with my list, which is an empty string, an O, and another empty string. So the O starts off in the middle. And then what I'm going to do is I will have a mixed up version of this list, and I will call equals shuffle list on my list. So that's step 2. And this is where I'm also going to grab the user guess. So I'll say guess is equal to the result of player guess. And then I'm going to check the guess. So we'll say check guess. And that will pass in the mixed up list along with the user guess. So this is really where the functions start interacting with each other, because I will shuffle and get a mixed list, and then I will get the player guess. And this third function takes the results of those 2 other functions. And this is what's going to allow you to write much more complex code. The fact that you can have separate functions doing separate parts and then interact with each other later on within another function. So you can see here that I'm actually able to write more complex code because I've been able to compartmentalize a lot of these functions and a lot of this complexity to just certain function calls. So this is really easy to read, and then if I ever have a question on what player guess is or what shuffle list is, I can review by going back up and checking my function definitions. So I can begin creating really complex code that is still actually quite readable. So let's run this and see how it works. So it says pick a number, 0, 1, or 2. Let me just input a wrong number to make sure it's still working. I hit 8, it asks me again. Looks like that's working. Let's just guess location, index position 0, see if I get lucky. I have 1 in 3 chance of getting it right. And it was a wrong guess. So notice here, I said 0, 0 is empty string, and it's currently lying at index 2, which also lets me know that the shuffle list is working because my initial list had the O at index position 1. All right, that's it. Go ahead and check out the lecture notebook in case you have any more questions on this. It's kind of set up in a step-by-step manner there, or you can post the Q&A forums if you have any questions. If you're trying to follow along but you're getting errors, make sure you try running our notebook first to make sure you didn't commit a simple typo. Thanks, and I'll see you at the next lecture.